First deployed in the early 1950s, the B-52 served as Strategic Air Command's primary deterrent weapon. Its range allowed SAC's nuclear arsenal to be deployed worldwide. The B-52 has been used for low-level bombing and electronic warfare missions. When it entered service in 1955, it represented the peak of jet bomber design. However, its origins trace back to a Department of Defense decision made a decade earlier during wartime. For much of World War II, the U.S. focused on refining existing technology to keep production lines operating at the urgency war required. Piston engines saw significant advancements. These power plants propelled every American aircraft that engaged in the intense air battles of World War II. Even the formidable Boeing B-29, with superior speed, range, and payload capacity, still relied on piston engine technology. The B-29 was considered the pinnacle of aviation, but its technological superiority was quickly eclipsed by a new generation of aircraft. Early in the war, the U.S. was stunned to discover that Germany and Britain had developed gas turbine jet engines, capable of propelling fighters, far faster than the legendary Superfortress. In 1944, the American Army Air Force issued a requirement for an all-jet bomber fast enough to evade jet fighters. Contracts were awarded for no fewer than 5 different designs. However, another technological breakthrough, nuclear fission, brought the war to a swift and dramatic conclusion. A B-29 was used to deliver the weapon, and with a single bomb, the city of Hiroshima was obliterated in seconds. If one aircraft could unleash such devastation, perhaps vast bomber fleets were no longer necessary to win modern wars. The immense loss of life America endured to establish B-29 bases in the Pacific reshaped the requirements for the next generation of bombers. In the early post-war years, strategy focused on the ability to deliver atomic bombs over vast distances. The Air Force prioritized long-range intercontinental aircraft, a role that the Convair B-36 Peacemaker effectively fulfilled for a time. The massive B-36 was, in reality, a World War II-era design that arrived too late for combat. It relied on 6 enormous piston engines to achieve what were merely average speeds. Later, jet engines were added in underwing pods to boost its power. By 1947, the jet bomber project was beginning to take shape. That year, 5 submissions underwent testing, though by then they were classified as medium bombers. The B-45 was the first jet developed from the 1944 requirement and proved to be the second most successful. The simple yet effective 4-engine design was adopted by the Air Force and entered service in limited numbers, primarily for reconnaissance. Consolidated proposed the B-46 as another four-engine jet bomber. With its sleek lines, it was one of the most elegant aircraft of its era, and its performance as an early jet was respectable. However, Consolidated was deeply engaged in B-36 production, leaving the medium bomber project with low priority. Martin's B-48 was a bulky design that used 6 jet engines mounted in mid-wing clusters. Its most notable innovation was a bicycle-style undercarriage along the aircraft's center line, supported by 2 outrigger wheels on each wing. This design failed to interest the Air Force, and, like the B-46, its prototype was scrapped. Northrop, in an effort to compete in the jet bomber program, modified its existing piston engine flying wing by fitting it with 8 turbojets. The design was remarkably efficient and years ahead of its time. However, perhaps due to its radical nature, it never gained full government approval. Northrop's expertise in flying wings would prove invaluable 40 years later with the development of the B-2 stealth bomber. The B-2's wing has since become a symbol of cutting-edge aviation design. But in 1947, the concept was seen as too revolutionary. Undoubtedly, the most impressive proposal submitted to the Air Force came from Boeing. Its B-47 Starjet incorporated insights gained from German research on swept-wing technology. To maximize the efficiency of these wings, they were made extremely thin and flexible. As a result, the 6 engines had to be mounted on pylons and distributed across each wing. This design not only made engine maintenance easier, but also provided aerodynamic advantages at high speeds. Due to the wing's thinness, Boeing adopted the same fuselage-mounted bicycle undercarriage used on Martin's B-48. The Air Force accepted the B-47, and by the early 1950s, hundreds had been produced. By any measure, it was a highly successful aircraft, an example of the right design emerging at the right time. It also served as an invaluable testbed, allowing Boeing to refine its expertise in producing efficient swept-wing jet bombers. One challenge of early jet engines was their relatively long spool-up time, particularly during takeoff. To address this issue, Boeing developed several types of detachable rocket boosters, a system that became known as Jet-Assisted Takeoff, or JATO. Following Boeing's legendary piston-engine bombers, the success of the Starjet program solidified the company's strong relationship with the Air Force for years to come. The medium bomber project gave Boeing a crucial advantage in the race to develop a new long-range heavy bomber to succeed the B-36 Peacemaker, which was nearing the end of its service life. In an effort to keep the Peacemaker relevant, Convair designed an all-jet swept-wing version designated the XB-60. However, reworking an aircraft originally conceived during World War II failed to impress the Air Force. As early as 1946, Boeing had been tasked with developing a replacement for the Peacemaker. The company explored hundreds of concepts, ranging from ultra-large piston engine designs to aircraft using proposed compound supercharged power plants, as well as turboprops, jet engines driving propellers. However, none of these concepts delivered the dramatic performance leap over the B-36 that the Air Force sought. Once the efficiency of the B-47's fully swept wing became evident, Boeing proposed another all-jet design, loosely based on its medium bomber, but significantly larger. This concept was refined into Model 464-67, which the Air Force ultimately approved as the B-52. In October 1948, an order was placed for 2 prototypes, designated the X and Y models, though minor issues delayed the X model, making the YB-52 the first to be completed. Here, the YB-52 is seen undergoing tests at Edwards Air Force Base. Its overall shape and fighter-style canopy resembled the B-47, but it was much larger and offered superior performance. The B-52 also introduced several advanced features, including a fully steerable undercarriage that adjusted to remain aligned with the runway upon landing, even if the aircraft was drifting to one side. This capability remained classified for several years. Apart from the cockpit layout, revised to a conventional side-by-side airliner configuration, there were few external differences between the prototypes and the production B-52s. Work progressed rapidly on the B-52A, now officially named the Stratofortress. Only 3 B-52A models were built, but the B model, nearly identical except for minor improvements, entered full production. Extending the bomber's range was always a top priority. In-flight refueling, perfected in the late 1940s through Boeing's flying boom system, addressed many challenges. However, during the early days of the B-52 program, aerial refueling remained a difficult task. The first tankers were powered by piston engines, with maximum speeds barely exceeding the stall speed of the jet-powered bombers. Here, the Y model performs the delicate task of aerial refueling. Jet tanker refueling was clearly a safer and more efficient option. It wasn't until the introduction of the KC-135 Stratotanker that aerial refueling became both safe and practical. Another method of extending range was the addition of extra-large outboard wing tanks, like the one shown here, which could hold 3,000 gallons and be jettisoned during combat. By March 1954, B-52s were coming off Boeing's production line in Seattle. The aircraft then entered an induction program where air crews and aircraft were integrated into a cohesive fighting force. Inside the sleek B-52, crews of 6 learned how to operate the Stratofortress. After the B-36, they found Boeing's bomber to be much more cramped. Every available inch of the B-52 was dedicated to fuel, payload, and electronics. Where the Peacemaker featured 6 gun positions, the B-52 had only 1. Instead, the aircraft relied on its performance and the emerging technology of radar jamming for self-defense. The Strategic Air Command required the world's best bomber, and it made equally stringent demands of its crews. Aircrew members underwent rigorous training, ultimately becoming an elite corps of professionals, forming a team capable of handling the sophisticated aircraft they operated. For over a decade, the Stratofortress and its crew had one primary mission: to carry and deliver the thermonuclear hydrogen bomb. But for the bomb to serve as a credible deterrent, it had to be tested to demonstrate its effectiveness. Throughout the 1950s, hydrogen bombs were detonated in remote areas of the Pacific. The final tests, like many before them, saw B-52s dropping the deadly payloads. For these men, loading the most destructive device ever devised by the human mind is a precise and routine task. It was a specialized job for the highly trained members of the Strategic Air Command team. Each device had a 100 megaton yield, 100 times more powerful than the bombs dropped on Japan. Unlike the World War II-era bombs, the device in this bomb bay would be slowed during its descent by a parachute, giving the bomber more time to vacate the area before the catastrophic explosion. Fearing a Soviet atomic strike, the United States established an extensive network of early detection systems during the Cold War. These early warning systems were mostly located in the frozen north, the most likely path for a first strike. Radar operators constantly monitored scanners, searching for the blip that could signal the onset of World War III. The Strategic Air Command maintained fleets of B-52s on operational standby in a constant state of alert, ready to serve as the ultimate deterrent if needed. When the red phone rang, the procedure was automatic. Up to 100 Stratofortresses could be deployed within minutes. This routine was honed through regular exercises. The concept of an immediate retaliatory strike by SAC was considered the nation's best defense during the Cold War. The responsibility of nuclear deterrence was entrusted only to carefully vetted officers. All B-52 pilots assigned to carry nuclear weapons held at least the rank of major. They carried the weighty responsibility of commanding aircraft capable of altering or even ending life on Earth. However, just as jets replaced piston engines, the B-52 and its high-flying Soviet counterparts were eventually surpassed by an efficient and lethal new technology born in Nazi Germany. By the early 1960s, ground-to-air missiles had been perfected by both the US and the Soviets, to the extent that large-scale nuclear bombardment by aircraft was becoming increasingly difficult. The focus shifted to another method of delivery: intercontinental ballistic missiles. Years of development had led to the creation of the Polaris and Minuteman missiles, among others, meaning that manned flights over enemy airspace were no longer necessary to wage full-scale nuclear war. Despite this, SAC's Stratofortresses remained in service. They still played a significant role in the high-stakes game of nuclear brinkmanship. The problem with ICBMs was that, once launched, they could not be recalled, removing the option for politicians to engage in the traditional tactic of saber-rattling and raising the risk of an unintended international conflict. The B-52, in combination with Hound Dog standoff bombs, offered a flexible alternative. B-52s could approach the edge of enemy airspace, signaling America's readiness to strike, while still allowing time for last-minute diplomatic negotiations. The B-52's effectiveness was further enhanced with the development of the Quail decoy, which mimicked a Stratofortress radio signal to confuse enemy radar. Following the Hound Dog missile, the SRAM, Short-Range Attack Missile, was developed. Smaller and capable of being carried in greater numbers, the SRAM could be guided from within the B-52 to targets up to 100 miles away, with deadly accuracy. In 1965, the B-52 was used for the first time in Vietnam. Although it carried conventional bombs instead of nuclear warheads, it remained a formidable weapon. The wing mounts now held 24 500-pound iron bombs, and the internal bomb load brought the total payload to 108 bombs per plane. Throughout the Stratofortress's involvement in Southeast Asia, B-52s dropped over 3 million tons of bombs. While the use of high-flying bombers was controversial at the time, there is little doubt that the Stratofortress was highly effective in conventional bombing operations. Many historians argue that the heavy bombing of North Vietnam during the linebacker operations forced the enemy back to the negotiating table, eventually leading to a ceasefire. In other Vietnam operations, more advanced bombs were deployed. Some bombs could be detonated later by personnel in different aircraft, using infrared viewing equipment to time the explosions with enemy movements. Standard 500 and 750-pound iron bombs like these were commonly used on most B-52 raids. To ensure quick loading and turnaround, the internal bomb load was stored in prearranged racks, allowing for the fastest installation possible. Crews initially based in Guam prepared for the long 8-hour flight to their distant target. The crew in the front and the solitary rear gunner took their positions as each aircraft readied for takeoff. During the long years of the Vietnam War, nose art appeared on several B-52s. Though the artwork was more subdued compared to its Second World War counterparts, the missions were no less dangerous. B-52 crews had to contend with fast and agile enemy MiGs, anti-aircraft fire, and, most dangerously, deadly surface-to-air missiles. Despite these challenges, they had their missions to carry out, and, like all soldiers, they flew regardless of the opposition. After a raid, ground crews rushed to repair the bullet-riddled airframes of returning Stratofortresses, preparing them for the next mission. Sometimes the damage was alarmingly close. Despite the low fuel takeoff policy, the heavy bomb loads placed immense strain on the engines, which frequently required maintenance and often complete replacement. MiGs were kept at bay and sometimes shot down by rear gunners, who, in their isolated positions, used a radar-guided, remote-controlled array of 4 cannons with formidable firepower. The tail gunner's position was removed with the introduction of the B-52G and H models. All B-52G and H models are equipped with EVS, electronic visual systems, which allow the pilot and crew members to see ahead of the aircraft, even in darkness or fog, through infrared television cameras displayed on a monitor. This innovation came just in time as the B-52's role shifted to that of a low-level tactical bomber. Stratofortresses may need to fly through atomic clouds, and with the B-52 shielded by radiation-proof curtains, the EVS becomes the crew's only visual connection to the outside world. Though the mission has evolved, the red phones and flashing lights remain the currency of SAC. When the alert sounds, whether in exercise or war, SAC's powerful deterrent force quickly swings into action. The first move for a general in charge of operations is to leave the ground base for the safety and mobility of an aerial command post. As the alert is given, air crews rush to their aircraft, always on standby for immediate deployment. The general is airborne, with B-52s following close behind. In the air is where SAC's deterrent force can survive an attack and simultaneously be in position to deliver a response. High-speed takeoff is crucial for survival. In this exercise, preparation for a nuclear flash is part of the procedure, and radiation-resistant curtains are deployed. The crew is entirely reliant on the EDS and other electronic systems, as they dare not look out of the cockpit. Flying low over the ground, each pilot waits for orders. The B-52s may have been called back during the exercise, but the demonstration reinforced the understanding that these aircraft still possess the capability to penetrate enemy territory, if necessary. The exercise concluded successfully, with the general reassured of the B-52's effectiveness. After 70 years of service, the B-52 continues to perform its mission, though its longevity indicates that its time in active service is nearing an end. From the outset, the Strategic Air Command had been looking for a replacement for the aging bomber. The first contender, the XB-70, was an ambitious and advanced design. However, it quickly became outdated as ground-to-air missile technology evolved, rendering it less effective. The B-1 bomber, developed by Rockwell International, emerged as a potential replacement. The B-1 combines high speed and altitude capabilities, utilizing its variable sweep wings to maximize both performance at higher speeds and fuel efficiency during low-level flying. The B-1 offered a balance of characteristics that made it an appealing successor to the B-52. The cost of deploying large numbers of B-1s was a key factor in the decision by the Carter administration to shelve the project throughout the 1970s. However, in the 1980s, the B-1B was revived and went into production, though not for its original high-altitude role. Instead, it was adapted as a low-level bomber, focusing on penetrating enemy defenses with its terrain-following capabilities. Around 100 B-1Bs were deployed by the Strategic Air Command. While the aircraft proved to be costly, it demonstrated its value in comparison to its predecessor, the B-52. The B-1B's performance, combined with the lessons learned from the B-52's decades of service, ensured it remained a vital asset for the U.S. military. Even after 7 decades of service and through rapid advancements in military technology, the B-52 continues to be an extraordinarily powerful and effective weapon. Its long-lasting legacy is a testament to its unparalleled versatility and capability, and it will undoubtedly be a tough act to follow for any future bomber designs.
This is the Rockwell B-1 bomber. It is one of only 4 prototypes ever produced. Had it been accepted by the United States Air Force, it would have been the fastest and highest flying bomber ever to go into service. The paradox is that the plane that ultimately did see service, although looking almost identical, flew at half the speed of the B-1 but was much more effective. The Air Force request for proposal, released in 1969, asked, among other things, for low-altitude ride control and nuclear hardness, the ability of the aircraft electronic system to resist the effects of a nuclear explosion. Again, the North American company took the lead. Now under its new banner, Rockwell put forward a concept that embraced the latest innovations, including swing-wing technology, but in proportions of a long-range heavy bomber. To prove the concept, an exhaustive wing tunnel program tested the shape, proportions, and function of Rockwell's proposed swing-wing penetrator. In miniature, every flight characteristic and operational idiosyncrasy of what was to be the B-1 project underwent the closest scrutiny. Throughout the verification process, models were used in many different ways. Here, another scale replica of the B-1 using the same non-radar reflective materials as the final aircraft is tested. On a movable rig, its ability to hide from radar coming from any angle is thoroughly examined. The biggest and most impressive model in this process was the final full-scale mock-up. This faithful representation of the designer's ideas gave the manufacturers and the Air Force the feel of the final aircraft, in those years before computer technology made it unnecessary. The mock-up gave the last opportunity to explore the practicality of the concept before committing it to the expense of production. Even details like hinged doors and access panels are faithfully modeled so that the ground and flight crews alike can assess almost every physical detail on the finished aircraft. A variety of model weapon loads, both outside the aircraft and inside the bomb bays, look absolutely convincing and provide the closest possible insight to the real thing. So does the layout of the cockpit, and even the swinging mechanism of the wing works just the way it will on the production version. This level of perfection is a test to the model maker. What manufacture of the real thing was to challenge the engineer far more. There had been problems with the early F-111 wing box on which the swing wing pivoted. The B-1 bomber would carry a load many times greater than the F-111, so this facet of its operation was tested in the most punishing way. As always with the United States military aircraft, the greatest consideration was placed on the service's most indispensable asset. The preservation of aircrew was a major priority, and with the B-1 project, it would prove a substantial challenge. Rockwell's engineers tackled the problem of crew survivability from a stricken plane in exactly the same way General Dynamics had with the F-117 crew capsule. But for the B-1, with a crew of 4, it would have to be much larger, and tolerances would be greater. There was always concern about the effects on aircrew, not only from the force of ejection, but more importantly from the impact of landing. The F-111's capsule had worked well, but at this scale and at the weight of 9,000 pounds, the problems multiplied. There was a real danger of spinal damage to crews on impact, so rapid-action airbags were developed to cushion the effects of the module as it hit the ground. Because of the nature of the B-1 mission, the airbags would have to work on land and on water. Meanwhile, at Palmdale, California, construction of the 3 prototypes began. The B-1 project was now underway, even if its long-term future was far from certain. Funding, as in most major defense projects, was to be a continuing problem. Cynic criticisms of the enormous costs of the V-1 and the usual inter-service competition for the military budget were as difficult for Rockwell executives to handle as the new technology was for Rockwell's engineers. Here, the dedicated test rig is used to assess tolerance to stress to prove the integrity of the B-1's basic design. That integrity would have to be confirmed before any plane with the performance expectations of the B-1 could be allowed to fly in service. Eventually, after years of gestation and months of production, the first B-1 was displayed to the public on October 26, 1974. Its sleek lines were emphasized by its glossy white finish. At the time, it was the largest swing-wing aircraft in the world. The first V-1, serial number 74-158, rolls down the Palmdale runway on December 23, 1974, for its first maiden flight. Originally, plans called for 5 flying prototypes and 2 for structural testing, but because of cuts to the program, only 3 planes were ordered. The second and third of these were not to be available for flight testing for over a year. So on the first flight to the first plane, more than usual precautions were taken without a ready replacement. Loss of this prototype could cause the whole program to collapse. Little surprise, then, that the first short flight to Edwards should be accomplished with wheels down. Nor was any attempt made to alter the position of the enormous swinging wings. But the 2-man crew did adjust the jet exhaust system. This complicated arrangement is sometimes referred to as the turkey feathers for obvious reasons. To control the final stages of up to 30,000 pounds of thrust with full afterburner is a difficult but vital function. Edwards is the traditional base for testing. Once called Maroc, this Air Force facility has been the home of many major test programs. Here, from the dry Californian desert, the first B-1, with the hopes of Rockwell and the Air Force in the balance, would undergo the most thorough flight testing. All the while, its detractors looked for the slightest flaw to capitalize on. Already, there had been problems with cost overruns. These had been added to by the government decision to produce fewer planes, substantially increasing the unit cost. Also, the decision to stretch the early delivery schedule created problems with the aircraft's 3,000 subcontractors. Logistics must have been a nightmare. Although the first short flight of the B-1 was a totally successful exercise, its future was still far from secure, and much of the real flak the program was to encounter had little to do with the plane's performance. Rather, the arguments were of need, philosophy and politics. Did the Air Force really require a new bomber? How valuable was a recallable man deterrent? Genuinely informed assessments of whether the B-1 might be able to achieve its mission requirements were less easy to find, and, against this backdrop of uncertainty, engineers and test pilots would have to prove Rockwell's super bomber. As the testing continued, the sole flying example of the B-1 was carefully put through various stages of the test program. Soon, the enormously powerful and complex landing gear was to be retracted and extended. Years earlier, when Rockwell was still called North American, and it was testing the XB-70 Valkyrie on its first prototype mission, the gear failed to retract properly, but the B-1's initial attempt at a clean profile flight was a total success. With something as complicated as the undercarriage, tremendous effort is expended in testing prior to flight, but in the end, the one that really counts is in the air. Throughout 1975, Rockwell's single-flying B-1 ran a gauntlet of tests, including the crucial wing sweep function from straight wing to delta shape. There was a comprehensive testing of the 4 General Electric F-101 fan jet engines and of the delicate task of aerial refueling, necessary even for a plane with the range of the B-1. It was tested in high-level flight at over 50,000 feet, then down to the deck for the all-important below-the-radar barrier trials, flying over 600 miles an hour at less than 200 feet. In these circumstances, the small vanes of a low-altitude flight control system were vital. Government cuts to the program meant that only 3 prototypes were to be built. The first of these was to fly, and the second was for structural testing. At the end of 1975, the stress tests were complete, and the aircraft was released to be fitted out for flying, but it would not be available till May the following year. In January of 1976, the third aircraft built for flight testing came online. This aircraft would concentrate on much of the complex avionics equipment used in the B-1 program, especially the Boeing-built offensive electronic system, a vital part in the B-1 mission. Inside the cockpit of these prototypes, a complicated array of dials and meters surrounds the cathode ray tubes. If you look closely, you can see the fighter-like control columns, unusual in the large aircraft. Directly behind the pilot and co-pilot, the other 2 crew members sit in their positions. The defensive and offensive systems operations use the high point of radar development not only to identify and target the enemy, but also to fend off attacking opposition fighters. It's a far cry from the air gunner huddled in the rear of the B-17. The B-1 crew fly in comfort, but in combat, they'd face the same old risks fighting off the late 20th or 21st century bandits. As the testing of the first 3 aircraft continued, with the speed and altitude envelope being constantly pushed, a 4th plane authorized for August 1976 production started its early stages of construction. With this latest B-1 underway, it seemed a program that gained significant momentum to survive its critics. With so much research behind it and so many of the problems solved, I appeared certain the Rockwell bomber would continue into production. But then, on June 30th, 1977, the recently elected Carter administration canceled the project and the B-1 program came to a halt. A unit cost of over $100 million was not the least of the reasons for cancellation. But there were others. One influential factor was the earlier success testing of a unique combination of 2 proven pieces of American hardware, a Minuteman missile and an AC-5 transport aircraft. It could be demonstrated that the C-5 was capable of launching the missile in flight. Then it could offer the Air Force an extremely cost-effective form of recallable deterrent. The survivability of a massive transport aircraft as it approached the combat zone may not have been great. But the extra range offered by the missile may have combined to produce some form of deterrent if the experiment worked. Although it was not to be adopted as a complete system, the air launching of an ICBM was nevertheless a spectacular achievement. It may yet have some potential. A much more concrete threat to the B-1 came in the form of the Aero-Launched Cruise Missile, or an LCM. These are clever and extremely deadly weapons. Before extension, their wings and tailplane fold flush to the main body so that many such missiles can be carried under the wings or in the internal bomb bays of the B-52. The AICM program, which was quickly implemented by the Carter administration, gave the aging B-52s a new lease on life as a suitable delivery system. The cruise missile uses small air-breathing jet engines, and with their extended wings and subsonic speed, obviously owe something to the original cruise missile, the German V-1 of World War II. But 30 years of technical evolution enabled the addition of concepts similar to the terrain following radar first used in the F-111. This produced a weapon that was at the same time economical and effective, and considerably extended the range and survivability of the B-52. One thing was certain: after the Carter decision to cancel the B-1, the B-52, old as it was, would have to carry on as America's only long-range recallable deterrent. But, although more life could be squeezed out of those remarkable aircraft, it was equally obvious that in the long term, a new delivery platform of some kind was inevitable. Even with the support of dedicated bomber versions of the F-111 and the ACMs, the heating power of America's strategic air force was starting to wane. In spite of the discussed conversion of transport aircraft to carry cruise missiles, it had been known for many years that survivability over or even close to the enemy's airspace required specialized aircraft, and the missile-carrying transport would be limited to a type of delivery far less challenging than the Air Force would expect from a B-52 replacement. Clearly, a long-range penetrator was needed. Although the Carter decision had cancelled production of the B-1, it had allowed some funds for the continued tests of the first 3 planes and to complete the building of the 4th. It was with these 4 aircraft that Rockwell started to resurrect the program. But much time had passed since the cancellation, and, if the swing-wing bomber was ever to reach production, it would be vastly different from the original concept. In some ways, time had worked into the plane's favor. New ideas were now becoming available, and with flying test vehicles on end, their qualities would be quickly verified. The most important change to strategic thinking was the revised attitude toward high speed. The first parameter for the B-1 had been that it could fly at over 50,000 feet and speeds in excess of Mach 2, twice the speed of sound, and then, as it approached the enemy radar, the plane was expected to drop to 200 feet in high subsonic speed to make its final run undetected. But later thinking claimed that Mach 2's speed performance was of no real strategic value. Low and slow, if 600+ miles an hour is slow, was seen as the best way for a long-range penetrator to reach its target. The reduction in top-end speed requirement would enable other benefits to be introduced in the new plane and would also contain costs. Much greater emphasis was placed on making the plane invisible by using non-radar reflecting materials. The new bomber would appear to be less than 1% of the size of a B-52 on enemy radar screens. In-flight refueling for optimum range was given even greater priority, as there had been unfounded criticism of the early plane's results at low level, A major change was implemented for crew survival. By deleting the crew ejection module, which had never been perfected, in favor of conventional ejection seats quite suitable for the slower flying version. With revised specifications from Rockwell and the pressing need to solve the B-52 replacement problem, the Reagan administration announced in October of 1981 the decision to build 100 Rockwell bombers, to be called the B-1B. The 4 earlier prototypes, which had done so much valuable work to prove the basic and later the modified concepts, would continue in test programs as the B-1A. It is entirely possible that had these 4 original aircraft not been available, the entire B-1B, the born-again bomber project, would have never gone underway. The B-1B was to have many new features, including a modified and vastly improved bomb bay. These cavernous areas can now be adjusted to accommodate different weapons, loads, and fuel requirements. Given the success the cruise missile had enjoyed, it would also have to be accommodated. Because the B-1B would be the B-52's replacement, the new aircraft would have to accommodate conventional and atomic devices in variety of sizes and configurations to fulfill a range of operations. Given this need for flexibility and the far-reaching scope of the B-1 project, it's hard to imagine that serious consideration was not so long ago given to use transports like the C-5 to carry cruise missiles, and that this combination was supposed to replace the classic B-52. As the B-1A continued to prove the new performance specifications, work on the B-1Bs was well underway at Palmdale. The total cost of 100 B-1Bs was to be $20 billion, or over $200 million a plane. But with the lessons learned from the disruption of the earlier program, at least the B model was certain of completion, and this meant, in the long term, the best value for the money. Much of the B-1B's cost goes to provide its sophisticated avionics equipment. Fixed antennas and radar dishes literally project from every angle of the fuselage, all gathering information for its computers to analyze. From this data, the crew will make decisions that may well resolve the outcome of a mission with historic importance, and the fate of the aircraft and those that fly it could equally be at stake. All things considered, perhaps the Rockwell swing-wing bomber is not so expensive after all. Many types of skill and technology are employed as the tens of thousands of parts come together, and the giant technological jigsaw puzzle that is the making of a modern bomber starts to take shape. By the middle of 1983, the first B-1D production model was ready to make its public debut. Looking so very much like its predecessor, the new planes are hard to distinguish from those which had first appeared almost a decade earlier. Modified air intakes and a small window for the radar operators are subtle but effective clues for the untrained eye. However, the performance variations are not so subtle. The B-1B, flying with half the speed potential of an A model, uses 21st century materials to become the most invisible to enemy fighters and missiles, and therefore is far more likely to complete its mission. And all the time it's on its deadly journey, it's providing tacticians with the flexible option of a last-minute recall. A role only the manned bomber can perform, but a role that was often understated in the past. Having survived against competition that started with such crude weapons as the V-1 flying bomb, and later evolved into the sophisticated and extremely deadly cruise missiles that would be carried by the aging B-52s, and having been eclipsed by the development of ballistic missiles, which began with the German V-2 rockets, and over time, developed into the powerful intercontinental ballistic missiles that have completely dominated the topic of nuclear delivery for over 30 years. The manned bomber survived by using yet another German innovation, the one of the variable swept wing. In the early 60s, the idea, greatly refined and used in conjunction with terrain following radar, emerged as the F-111, a very successful medium strike bomber. And in the early 70s, the concept was further developed into the B-1, the ultimate high-speed, long-range, manned bomber, when it was to take another 10 years, and the arrival of still more advanced construction materials and another generation of avionics before the later model, the B-1B, was able to reach service. A masterpiece of high technology, the best that aerospace industry could offer, had finally arrived. It continued to fly well into the 21st century and doubtlessly became a legend similar to the B-52 we've replaced. But clearly, the B-1B, the born-again bomber, was already one of the world's greatest planes. In many ways, development of the B-1 paralleled development to the very first strategic bomber, the B-17, in that the B-17 also had to deal with an array of problems. The history of the B-17 began when the Army Air Corps circulated a specification for a multi-engine bomber. They probably only expected manufacturers to respond with a twin-engine design, but the Boeing company, showing what was to be characteristic foresight, offered a four-engine plane. As advanced as it may have been, Boeing's Model 299, as the prototype was known, was not very well received. An accidental crash in the early trials and a belief in some quarters that a large four-engine plane would be too difficult to fly in combat cost Boeing the initial order. And yet, certain factions in the Air Corps encouraged Boeing to continue development of what was, for its time, a massive aircraft. Using much of its own money and fighting government cutbacks, the company continued to develop what was ultimately to be a most important plane.
During the early 1900s, as America began to emerge as a global power, Roosevelt delivered a prophetic statement on international diplomacy, advising to speak softly but wield a formidable presence. 50 years later, amid the United States' role as the foremost defender against communism, its formidable tool was undoubtedly the Convair B-36, a long-range bomber. Although this immense aircraft served predominantly throughout the 1950s, its origins can be traced back to before America's entry into the Second World War. The B-36 earned itself the unofficial title of Peacemaker. By 1941, the United States Army Air Force had two effective heavy bombers in its arsenal. One was the renowned B-17, crafted by the Boeing Company. This exceptional four-engine aircraft played a crucial role throughout the war, with later heavily armed versions aptly dubbed the Flying Fortresses.